Picture this. You're on a ship, a really, really big ship. Not just any ship, but one of the largest and most formidable vessels ever constructed by human hands. This is a floating city, a marvel of modern engineering and naval prowess. It's a place where thousands of sailors live and work, a hub of activity and precision. The sheer scale of it is mind-boggling. We're talking longer than 3 football fields, stretching out over 1,092 feet. Imagine standing at one end and barely being able to see the other. It's a testament to human ingenuity and ambition. And it's not just long, it's tall too. Taller than the Statue of Liberty, towering over 20 stories high. This colossal structure is a fortress on the sea, designed to project power and maintain peace. This ain't your grandpappy's fishing boat. No, this is a leviathan, a behemoth that dwarfs anything that came before it. It's a symbol of technological advancement and military might. This, my friends, is a US Navy aircraft carrier, a floating airbase capable of launching and recovering aircraft with pinpoint precision. It's a mobile command center, a beacon of strength and resilience. Now imagine a storm kicks up, a real monster. The sky darkens, the wind howls, and the waves begin to swell. The ocean becomes a churning, chaotic force of nature, ready to test the mettle of this steel giant. Waves the size of skyscrapers come crashing down, towering over the deck and threatening to engulf everything in their path. The sheer power of the ocean is on full display, a reminder of nature's untamed fury. Tons of water slamming into metal, the sound is deafening, a cacophony of nature's raw power meeting human engineering. The ship shudders, but it holds firm, a testament to its design and construction. You'd think even a beast like this would crumble, right? The force of the waves is enough to make anyone doubt. But this ship is built to endure, to withstand the harshest conditions the ocean can throw at it. Wrong. These carriers are built to laugh in the face of Mother Nature's worst tantrums. They are engineered with precision, designed to be resilient and robust, to keep their crew safe and their mission on track. How? Let's dive in and find out. From the reinforced hull to the advanced stabilization systems, every aspect of these carriers is crafted to ensure they can handle the most extreme conditions. Join us as we explore the incredible engineering and design that make these floating fortresses virtually indestructible. First things first, size matters. When we talk about aircraft carriers, we're talking about some of the largest moving structures ever built by humans. These floating fortresses are not just big, they are colossal, stretching over 1,000 feet in length. Imagine 3 football fields, end to end, and you start to get an idea of their immense scale. These carriers are massive, displacing over 100,000 tons of water. To put that into perspective, that's the equivalent of the weight of about 400 Statues of Liberty. The sheer volume of water they push aside as they move is staggering. That's like 20,000 elephants doing synchronized swimming. Just imagine the spectacle of such a sight. This comparison helps us grasp the extraordinary mass and presence of these ships. This sheer size gives them incredible stability. In the open ocean, where waves can reach towering heights, the stability of an aircraft carrier is crucial. Their vast size and weight allow them to cut through rough seas with relative ease, maintaining a steady course even in turbulent conditions. Think about a kid's toy boat versus a barge. The bigger one's gonna handle choppy waters way better. The same principle applies here. The larger the vessel, the less it is affected by the waves, making it a more stable platform for operations. Then there's the weight distribution. On an aircraft carrier, this is meticulously planned and executed. The distribution of weight is a critical factor in ensuring the ship's stability and performance. It's like a perfectly balanced seesaw, spread out evenly to prevent tipping. Every component, from the heaviest machinery to the lightest equipment, is strategically placed to maintain balance. Heavy stuff like engines and weapons, down low. This lowers the center of gravity, making the ship more stable. The lower parts of the ship house the heaviest equipment, ensuring that the weight is concentrated where it can best contribute to stability. Lighter stuff like living quarters, higher up. The upper decks are reserved for lighter components such as living quarters and operational spaces, which helps in maintaining the overall balance of the ship. It's all about that center of gravity, folks. The center of gravity is a crucial aspect of naval architecture. By keeping the center of gravity low and balanced, these massive ships can navigate the seas with remarkable stability and efficiency. This careful balance ensures that aircraft carriers remain the formidable and reliable giants of the ocean. Now, let's talk about that hull, the underwater part of the ship. This part of the vessel is often overlooked, but it's one of the most critical components. The hull is designed to withstand immense pressure and force from the ocean. It's not just a barrier, it's a shield that protects the ship from the harsh marine environment. The materials used in constructing the hull are specially chosen for their strength and durability. Engineers spend countless hours testing and refining these materials to ensure they can handle the toughest conditions. It's not just some big, dumb hunk of metal. The hull is a sophisticated piece of technology. It's designed to be hydrodynamic, meaning it can move through water with minimal resistance. This is crucial for the ship's speed and fuel efficiency. The shape of the hull is carefully calculated to reduce drag and improve performance. Every curve and angle has a purpose. The hull also plays a vital role in the ship's stability. It helps to keep the vessel balanced and prevents it from capsizing in rough seas. It's a masterpiece of engineering designed to cut through waves like a hot knife through butter. The bow, or the front part of the hull, is particularly important. It's shaped to slice through oncoming waves, reducing the impact and making the ride smoother for everyone on board. The design of the bow is the result of years of research and development. Engineers use advanced computer simulations and scale models to test different shapes and configurations. The goal is to find the perfect balance between strength and efficiency. The bow, the pointy front part, is shaped to pierce oncoming waves and minimize impact. This design helps to reduce the amount of water that splashes onto the deck, which can be dangerous for the crew. The bow also helps to improve the ship's speed and fuel efficiency. By cutting through the waves, the ship can move more quickly and use less fuel. This is especially important for long voyages where every drop of fuel counts. And don't forget those powerful engines. These engines are the heart of the ship, providing the power needed to move through the water. They are incredibly complex machines designed to operate under extreme conditions. The engines are carefully maintained by a team of skilled engineers who work around the clock to keep them running smoothly. The power generated by these engines is immense, allowing the ship to travel at high speeds and navigate through rough seas. These bad boys can muscle through the roughest seas, keeping the ship pointed into the waves, which is crucial for stability. The engines work in tandem with the hull to ensure the ship remains stable, even in the most challenging conditions. The ship's navigation systems also play a key role in maintaining stability. These systems use advanced technology to monitor the ship's position and make adjustments as needed. The goal is to keep the ship as steady as possible, minimizing the risk of accidents and ensuring the safety of everyone on board. Imagine trying to stand upright while being blasted by a fire hose from the side. That's what it's like for a ship in rough seas. The force of the water can be overwhelming, making it difficult to maintain balance. The ship's design and technology work together to counteract this force, keeping the vessel stable and on course. The crew also plays a crucial role in maintaining stability. They are trained to handle rough seas and know how to respond to different situations. Their experience and expertise are invaluable in ensuring the ship's safety. Not easy, right? Same principle here. The ship's design, technology, and crew all work together to keep the vessel stable and on course. It's a delicate balance, but one that is essential for the safety and success of the mission. The next time you see a ship slicing through the waves, remember the incredible engineering and teamwork that make it possible. It's a testament to human ingenuity and the relentless pursuit of excellence. But wait, there's more. These carriers have some secret weapons up their sleeves. Well, more like deep inside their hulls. They're called stabilization systems, and they're like the ship's own personal force field against rough seas. Think massive fins that jut out from the sides, constantly adjusting their angle to counteract the wave's rolling motion. They're like those self-balancing scooters, but way bigger and way more important. Now let's talk power. These carriers don't run on diesel or gasoline. No, sir, they've got nuclear reactors humming away down below. That means near limitless energy to power those massive engines and keep the ship steady no matter what Mother Nature throws at it. Plus, nuclear power means they don't need to refuel for years. Imagine being stuck in a hurricane and running low on gas. Not a good situation. But these carriers, they just keep chugging along, a shining beacon of American might in the face of adversity. But here's the thing about these carriers. They're more than just steel and technology. They're crewed by some of the toughest, most highly trained sailors on the planet. These men and women are the real heroes, the ones who keep everything running smoothly when the going gets tough. They train for years to handle any situation, from fighting fires to navigating treacherous waters. They're like a well-oiled machine, working together to keep the ship afloat and everyone on board safe. So how do these aircraft carriers survive those monster waves? It's a combination of factors, a symphony of strength and skill. The sheer size and weight distribution provide a stable platform. The specially designed hull cuts through waves, while the stabilization systems and powerful engines keep it steady. And of course, none of it would be possible without the dedication and expertise of the incredible crew. These carriers are a testament to human ingenuity and determination, a symbol of American power projected across the globe. They are built to withstand the harshest conditions imaginable.